Hey guys, this is Shelby with the Rogers Public Library. So this week for Full Steam Ahead, I wanted to talk to you guys about proteins. So just like we've talked about fats and carbohydrates, right? Proteins are macronutrients, right? They're one of the major things that we need to eat in order to sustain ourselves. And they're also like carbohydrates and like fats, polymers, right? So they're really big molecules that are made up of smaller molecules. And in the case of proteins, these smaller molecules are called amino acids, right? So amino acids, right? They're acidic. They also have what are called amine groups in them. You really need to know what that is, right? They're just kind of related to ammonia, and it has to do with like scientific naming stuff, right? But amino acids, right, when they link together into long chains, they can be called, sometimes they're called peptides, right? That's kind of a scientific name, right? And then if there's enough amino acids, if there's more than 50 in the chain, then you call it a protein, right? So we use proteins for a lot of things, right? So we've talked about enzymes on here before. Enzymes are proteins, right? Enzymes are also like hormones, and they do a lot of other things in our body as well, right? So they're kind of they do, you know, they help us regrow tissue, and they just kind of keep everything working. And so the way, but proteins are a little bit different in that. So right, so with carbohydrates and fats, right, the main thing that makes them work, so to say, is their molecular structure, right? So how the different atoms in the molecule are arranged together. And so proteins have a molecular structure, right? Like that, right? So there's like nitrogen atoms next to oxygen atoms, next to hydrogen atoms, and all of that. But they also have a three-dimensional structure, right? So you can think of like, right, so we have like a chain of amino acids like this, but an actual protein might look like this, right? And if you look up pictures of proteins, like on Google or Wikipedia or something, you'll see these really weird blobs of stuff, right? With really complicated structures. And these structures are, to a certain extent, just determined by the like the arrangement of amino acids in the protein, but they're also determined by things like our body temperature and the pH inside of our inside of our bodies as well, right? So, but the cool thing about the proteins we eat, though, is that when we cook proteins so that we can eat them, what happens is they're denatured, right? So denatured means that they're changing out of their natural state to kind of an artificial one. And that usually looks like straightening up the molecule. And I'm going to do a little science experiment here with some eggs. So you'll want to wash your hands before you do this, right? I'm not super worried about that because I'm not going to be eating these. But the first thing you'll do is you'll crack open an egg and you'll filter out the yolk. Okay. This is an easy way to do this. You can also use like a spoon or the eggshells or several different ways. But I'm not really concerned about getting messy, right? At least in this personal, at least for me personally, right? Okay. So now the reason we're separating out the egg whites is because the egg whites are primary concerned. The egg whites, which are called albumin, they're primarily composed of proteins, right? Whereas these guys, the egg yolks, are have like fat and stuff in them, as well as some vitamins. I think the vitamin that makes them yellow is called carotene. All right, now, but now that we have this in here, I'm gonna go wash my hands real quick. I'm gonna show you guys two different ways to denature the proteins in the egg whites, right? One of them is easy. It's probably something you've done before, right? Is just cooking eggs, right? We're going to be cooking this one in the microwave. We're going to be doing something a little bit different and using acetone to denature this egg, right? So just a word of advice, right? So acetone, you might have this in your house already. It is nail polish remover, is maybe what you're familiar with calling it. It is not safe to eat, right? So you're going to want to do this with an adult. You're also going to want to do it in a well-ventilated area. And when you do this experiment, you have to make sure not to use plastic containers because acetone can melt plastic. In fact, it does a really good job at melting styrofoam, as well as several other types of plastic, right? So glass container, and preferably one that you don't eat food out of. Right. But we can already see a little bit what's happening over here is the egg whites are changing from this clear color to a kind of milky whitey color, right? Kind of like if you ever made eggs sunny side up before, you'll kind of recognize this color, right? Now I'm gonna just let this one sit for a little minute, and then put this in the microwave, and then we'll come back and talk about it. So I put this one in the microwave for about 25 seconds. You can see it is looking pretty similar to this one over here. This one is maybe not quite as uniform, right? It hasn't fully denatured, but this one has, right? Just thanks to heat. Eggs actually start, cooking at a relatively low temperature, around like 104 degrees Fahrenheit. So they cook really fast in the microwave. But anyway, the reason why this happens is that when the proteins denature, they start getting kind of tangled up together, right? And as this happens, they form a big blob or an aggregate, right? And so instead of being a bunch of like smaller proteins that are kind of just chilling by themselves, they're now like one big thing, right? Kind of like this. So I'll see if I can pick this up. I don't really want to try to use my hands because it's still hot. So that's what a denatured eggs looks like, right? And denaturation, this is like one of the main processes that we associate with cooking, right? It's what makes egg whites white. It's what turns raw meat from red or pink to like white or brown in the case of like beef and chicken. And it's also one of the processes that makes like a loaf of dough into or a piece of dough into a loaf of bread, right? So it's pretty cool. And then when you're done with the experiment, you'll want to just dispose of your stuff, right? You don't really want to pour this down the sink, right? Because it's got a lot of like not water soluble stuff in it, and you probably want to dispose of it like out of the trash can outside. Would be for the best, because I don't know how acetone would react with like garbage bags. That might make a big mess. Anyway, so the craft for this week is pretty simple, right? It is a little 3D sculpture, right? So we talked about how protein molecules have these really cool 3D structures. So I thought it would be kind of cool to make a 3D sculpture kind of replicating that. Stick this in, and kind of just goes in, right? Right. The styrofoam is very soft, so the wires slide into it pretty easily. I'll make this one. This one looks a little bit like Pikachu, I guess. A little bit. And I guess I'm going to give him a tail. Okay, here we go. So that's our sculpture, right? It's really easy, and you can pick up everything that you need to make it here at the library. But that's what I have for you guys this week. I hope you had fun and you learned something, and I'll see you next time.